Good evening, and welcome to another episode of Triboelectric Nanogenerators. So this is I was looking earlier at Teflon pellets a couple days ago, and I had decided to also attempt a flag method, and so this is a nylon. This material here is nylon film. I believe it's 0.002 inches thick. And then I got some PTFE, which I got a little bit thicker. I think it's a 0.03 millimeters, something like that. It's like a third of a millimeter. I don't know. It's very, very thin material. And I hooked up this to a voltimeter. Well, let me just explain first. I put aluminum HVAC tape on either side of this. So there's 3 strips here. And on the other side of the PTFE, there is 3 strips. On the other side of that Teflon. Then there's just the material itself in the middle, right? So on this side it's just all nylon, and then this is all Teflon in here. So these 2 materials are different on the triboelectric scale, so that means that combining them and then pulling them apart or rubbing them together should generate a static electric charge between the 2, and then whichever side the electrons rip off of, I'm not sure if it's the nylon or the PTFE, I forget right now, but the electrons will rip off on one side and the other side will gain a whole, quote unquote, a positive charge, and those charges will collect on these aluminum strips and then go up here, and then I attached alligator clips which then go into these 2 LEDs here that are connected reverse polarity to each other. So one goes positive to negative, the other goes negative to positive, because this is going to generate an AC current, because as you pull it apart and then stick it back together, this is going to be a positive charge, then a negative charge, and then a positive charge, negative charge. And so that's an alternating current. And so what you normally would want is a rectifier to be able to capture that charge in both directions and make that positive. And then you would go into a capacitor. So anyway, so if I do this, it should light up these LEDs, and I'll show you in a second. But I just wanted to say, when I hook this up to my multimeter, you know, it's really hard to get instantaneous readings with like a Radio Shack multimeter. I do have an oscilloscope downstairs, but I don't really use it a lot. But on my multimeter, at least, I got like 2.6 volts, and that's kind of what I'm seeing with the LEDs. I can kind of eyeball it now. I've gotten used to the range of these LEDs. So as I'm currently lifting it up like this, I'm doing this. All right, so let's look at these LEDs. So yes, they're doing that. Okay, this actually looks a little bit better than it did a minute ago when I was testing. So yeah, it's probably about, I mean, they don't look fully lit up. Yeah, it's maybe about 3 volts. Almost 3, maybe 2.8 volts there. So they're switching back and forth, you'll see, right? Because I'm lifting it up and putting it back down. This is what I'm doing here. But then, so then the question is, how would this function in reality? So you can imagine you have a flag, and I'm pretty sure someone else did one of these before. I think that's where I got the idea from, is someone else. You create a flag like this, and then when the two pieces connect, then you end up with a voltage. And so if the wind is doing this to it constantly, that should light up the LEDs. I was able to get it to work before. If I smacked it up against my knee, I guess this is kind of hard to show right now. I would have to hold this still, and I'm holding my phone. But I was able to get them to light up by smacking it up against my knee. And you would say, hey, in the wind, this should work. But the problem again here is the surface area. And all of these really have to make simultaneous contact. Oh, it's lighting up now. But they all have to make simultaneous contact in order to get that voltage up high enough. So I guess that works. And what I've found is a lot better is this. Still. So look at this thing. This thing just lights up. This is a normal accordion style one. This is exact same electrical connections as this. So again, I just have two LEDs wired back to back between two electrodes that are folded together with different materials. This one has HVAC tape and Scotch packaging tape, which are normal things you can get at a hardware store. And then I actually attach the wires here with super hot glue. And then I normally put this whole thing inside of like a little pouch here, like this. So it says square TENG flashlight, squeeze TENG flashlight. So normally I'll stick it in a pouch, and then I just have an emergency flashlight that I can do this. That doesn't need batteries and just works all the time. And if there's an emergency, but I don't know. I feel like this design, I haven't really beat this yet. This is the best one. And I can definitely see if they had something like this on construction worker hats, so that as they move, it's lighting up and there's like an indication that they're moving. And then the batteries would never wear out, and it would be based on movement as a safety mechanism. And I'd imagine that would help for safety. Or bike lights, or someone jogging, you attach this to yourself and it lights up. And the weight for this is, feels like, it kind of feels like it weighs as much as like maybe 3 AA batteries actually. So I don't know, maybe the weight's a little heavy for that. But so back to this. I don't know. I always wanted to try using a sheet rather than a roll of tape. Some other method is kind of difficult because I have to wrap very long lengths of HVAC tape, at least one of the strands, with Scotch packaging tape to completely seal it, and that takes a lot of time. And then it takes time to fold the creases very well so that they line up and get enough surface area. And I was hoping, you know, maybe if you had just a sheet like this and it was large enough that it would be easier to construct something. But I haven't really thought yet of a way to do this better. I don't know. I also feel like the sheets, you know, I mean, part of the Triboelectric thing is that, you know, it generates a charge between the two sheets. It's like they're attracted to each other. And so if it's blowing in the wind, it's harder to separate these. And then if they're sheets, they're not going to separate as much. So I don't know. I feel like it's not. I feel like this design is not really worth the trouble. It's not very compact. And if you were doing something that was wind power, there's probably more efficient ways to do that with a wind turbine. But I guess, I don't know, form factor wise, if you did have a flag, if you had some location where you could put flags, but you couldn't put, you know, a wind turbine, maybe that would make sense. I think one of the videos I saw, someone had one of these flag type things outside, you know, sticking out of their car window, and it was going back and forth in the wind. Maybe I should try that out. But anyway, there it is. There's my flag TENG there. And thanks for watching. All right, bye.